Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. Dear students, Assalamu alaikum. My name is Ayesha Abdullah, Subject Specialist Maths at Divisional Public School and College Sahiwal. Students, I'll teach you Maths of Class 6 and this is your lecture number 6. As you already know that we are studying chapter number 8, that is Introduction to Algebra. So here are the contents include sum of algebraic expressions, exercise number 8.3, question number 3 and 4. Students, by the end of this topic, you will be able to know that like terms can be combined to give a single term. And also, you will be able to find the sum of the algebraic expressions. Firstly, we recall the previous knowledge. In previous lectures, you have learned about the like and unlike terms. The terms of the same kind only differ by their coefficients are called like terms. For example, here in this expression, you can observe that terms a, 2a and 3a have same variable a. Also, examine that the coefficient of these terms are different. Term 3a has coefficient 3, term 2a has coefficient 2 and term a has coefficient 1. As variables with no number have a coefficient of 1. So, like terms have same variables but coefficients do not need to match. Here in this expression, terms 32a raised to the power 2 and 9a raised to the power 2 have same variable and exponents. So, here you can observe that like terms have same variables and exponents, but the coefficients do not need to match. The terms having different variables or same variables with different exponents called unlike terms. For example, here in this expression, terms 2x and 19a have different variables x and a. And here in this expression, you can observe that both terms have same variable a with different exponents. Here you can see that the exponent of this variable a is 2 and the exponent of variable a here is 3. So you can observe that unlike terms have the same variable with different exponents or different variables with same exponents. Here you can see that exponent is 1, that is same. Students, in arithmetic, we can add only like things. This can be shown by an example. If 2 boys and 3 boys go to the school together, then we can say that 5 boys go to school instead of saying 2 boys and 3 boys, because we can add them together as given here. 2 boys plus 3 boys, that will become 5 boys. But when we say 2 boys and 3 girls go to school, then the sentence will remain as it is. This shows that we cannot add them together because they are not alike. Consider that if we denote boys by a variable x and girls by a variable y, then we can write the above two statements as. We just write x instead of boys, then this statement will become as. That will become 5x instead of 5 boys. Now this statement will become as. We just write x instead of boys and y instead of girls. Then this statement will become 2x plus 3y. But this statement will remain as it is. From these two expressions, we examine the rules that we use in addition of algebraic expressions. Rule 1. We can add only like terms and unlike terms will remain as they are. For example, you can see that we add only like terms 3p plus p and we get 4p. And the unlike term, that is 2q, will remain as it is. Rule 2. In addition of like terms, we just add their coefficients and write the same variable with the sum. For example, here you can see that in this expression, we just add the coefficient 4 and 5. That will become 9. And we just write same variable x with the sum. And we get 9x in this way. So here is the topic, exercise number 8.3, question number 3 and 4. Question number 3 is given over here, that is, add the following. The first part of question number 3 is given over here, in which we have to add these terms. In solution, for adding these terms, just remove the comma and put the plus sign just in between the terms. As you can see that, concentrate on like terms. Add the coefficient of like terms, that are plus 1, plus 1, plus 1, that will become plus 3. And we write the same variable BC as it is with the sum. And the unlike term AB will remain same. Now you can see that B is common in both of these terms. So we take B common, as by taking B common from this term AB, we are left with A here. And by taking B common from this term 3BC, we are left with this term 3C here. Remember that you cannot write here 3BC as you have taken B already common. So this is the answer. The second part of question number 3 is given over here, that is 2x raised to the power 2y, comma x raised to the power 2y, comma x y raised to the power 2. In solution, for adding, just remove the comma and put the plus sign in between the terms as I did. Now concentrate on the like terms. So these are the like terms, 2x raised to the power 2y and x raised to the power 2y. Now we have to add the coefficient of these like terms. 2 plus 1, that will become 3. And we write the same variable x raised to the power 2y as it is with the sum, and the unlike term xy raised to the power 2 will remain same. You can write this expression in this way just for the convenience. Now we have to take common x and y from these two terms. Just take common x y from this term, we are left with 3x here. And by taking common xy from this term, we are left with y here. So this is the answer. Students, you can skip this step. But if you have good skill to take common. The third part of question number 3, which is given over here, that is 6m raised to the power 3, 2m raised to the power 2, 1 and 3m raised to the power 2. In solution, we just add these terms. For adding, we have to remove the comma and put the plus sign instead of this comma. Now, we will concentrate on the like terms. So firstly, we will arrange the like terms together as we have to add the coefficient of the like terms. Plus 2 plus 3, that will become plus 5. And we write variable m raised to the power 2 as it is with the sum. Now we cannot add further because the terms 6m raised to the power 3, 5m raised to the power 2 and 1 are unlike. So this is the answer. The fourth part of question number 3 is given over here. Now we have to add these terms. So for adding, in solution, we will insert the plus sign instead of comma. So we have to remove comma and we will put the sign of plus here in between the terms. Concentrate on the like terms. So here we go. Plus 3ab plus 4ab are the like terms. Add the coefficients of the like terms. Plus 3 plus 4, that will become plus 7. And we have to write variable ab as it is with the sum. We write the unlike terms b raised to the power 2 and 2a raised to the power 2 as it is. Now we cannot add further because the terms b raised to the power 2, 7ab, 2a raised to the power 2 are unlike. So this is the answer. In the fourth part of question number 3, we have to add these terms. In solution, we just remove the comma and we will write the given sign in between the terms. Minus sign by removing this comma. We have to concentrate on the like terms. So there are minus 2q and minus q. So firstly, we will arrange these terms like this. Now we have to add like terms. So we will add the coefficients of like terms. Minus 2, minus 1, that will become minus 3. And the variable q we will write here with the sum as it is. Students, p and r are unlike terms. So we write p and r as it is. We cannot solve further or we cannot add further because these are unlike terms. Question number 4 is given over here, that is, find the sum of the following algebraic expression. In the first part of question number 4, we have to find the sum of these three algebraic expressions. In solution, we can add these three algebraic expressions by this method, which is called column-wise addition. Firstly, you have to arrange all the algebraic expressions in order. Secondly, you have to put the like terms in the same column as. Now, we have to add like terms together but column-wise. Now you can see that we have 3 columns and all the terms in these 3 columns are like terms. Firstly, you have to write the first algebraic expression as After that, you have to write second algebraic expression. Remember that we have to put like terms just below the like terms. For example, we have to write minus 2ab just right here below this one to make these terms alike. In this way, you will write this expression below this. Now you can observe that all the terms are alike in these columns. Now you have to add these terms because we can add like terms. Here the coefficient is 1. So 1 plus 1 plus 1, that will become 3. And we have to write the variable a raised to the power 2 with this sum as it is. Now we will add the coefficients of these terms in this column. Plus 2 and minus 2, that will become 0, means nothing. So we will cancel these terms and we are left with minus ab. So we write minus ab here as. Now add the coefficients of these like terms. Plus 1 plus 1, that will become plus 2. Plus 2 minus 1, that will become plus 1. And the variable b raised to the power 2 we write here as it is. You can also add these like terms in this way. Here add the coefficients of these like terms 1 plus 1 minus 1 in this way. 1 plus 1, that will become 2, and write minus 1 here. Now 2 minus 1, that will become 1, b raised to the power 2 or just b raised to the power 2, because you know that variable with no number has coefficient of 1. So this is understood. Students, this is the answer. The second part of question number 4 is given over here. We have to add these three algebraic expressions. So firstly, we will write this algebraic expression as. After that, we will write this algebraic expression as. Observe that like terms are just below the like terms. Now we have to write this algebraic expression. So for the term x raised to the power 2y, where we have to write this term just below the like terms. So we write here, as there is no sign with it, means plus sign. We will write plus x raised to the power 2y just right here, just below these like terms. After that, minus 2x raised to the power 3y, where we have to write this just below this. We have to write minus y raised to the power 2. So we write here. Now you can see that all these three columns consist of like terms. Now we have to add these like terms. 1 plus 1, that will become plus 2. Plus 2 and minus 2 will become 0. That means nothing. So by adding these terms, we get 0. So we cancel out these terms. Now plus 2 plus 1 plus 1, that will become plus 4. So by adding the coefficients of these like terms, we will get 4, and we have to write variable x raised to the power 2y as it is with this sum. Now we have to add the coefficients of these like terms. Plus 1 plus 2, that will become plus 3. Plus 3 and minus 1, that will become plus 2. And we have to write variable y raised to the power 2 as it is. You can see that we can take common 2 from these two terms, and also we can take common y from these two terms. By taking 2y common from this term, we are left with 2x raised to the power 2. We have taken y as common, so we write common part here. Now we have to take common 2, as we know that 2 multiplied by 2 is equal to 4. So after taking 2 as common, we are left with here 2. Now after taking 2y common from this term, we are left here with y, as 2 is common and y is appearing 2 times. So one y is taken common and the other one we have to write here. So here is the answer. In the fourth part of question number 4, which is given over here, we have to add these three algebraic expressions. So firstly, we will write first algebraic expression, that is 2b plus 3q. Now we have to write the second algebraic expression, that is 3q plus 3r. Now write 3q just below the like terms here. Students, where we have to write 3r here? No, that will not become the column of like terms. So we have to write plus 3r just here, because it does not match any of these variables. Now we have to write third algebraic expression, that is r plus 3p. Now we will write r just below this term to make the column of like terms, and write 3p just here below the like term. Now we will add the coefficients of like terms column wise. Plus 2 plus 3, that will become plus 5, and we write variable p as it is. Plus 3 plus 3, that will become plus 6, and we will write variable q as it is. And here plus 3 plus 1, that will become plus 4, and we will write variable r as it is. So here is the answer. You can see that we cannot take common anything from this expression. The fifth part of question number 4, which is given over here. Firstly, we have to write the expression b plus 1. After that, we have to write this expression. So where we have to write a? We have to write a here, because a does not match with any of these terms. Now we have to write plus b. Where we have to write plus b? Just below this term to make column of like terms. Now look at here, where we have to write plus 2 just below the constants. We write constants just below the constants to make the column of like terms. Now where we have to write 3, we will write 3 just below the constant terms. And now the fourth algebraic expression, a plus 1, we will write a just below this term to make it like. We have to write plus 1 just here. Now we have to add the coefficients of the like terms column wise. 1 plus 1, that will become 2, and b variable will remain as it is. Now add all the constants. We will get plus 7. Here plus 1, that will become plus 2, and we have to write variable as it is. So here is the answer. Now you can see that we cannot take common anything from this expression. So this is the answer. Here is an assignment for you. Question number 3, fifth part. Question number 4, third part.